yes, additional suggestions in addition to what we did yesterday. Technical recommendations about SimpleBox and SimpleTreat from Jaap Struijs and myself. And secondly, there's a recommendation that comes straight from the EU project Solutions, where we tested an integrated version of SimpleBox and SimpleTreat in order to test whether the emission estimates that were made in that particular project made any sense. And the conclusion was yes, they do make a lot of sense. And the conclusion was also, and this integrated model that we used for testing also makes a lot of sense. And the participants in the Solutions project believe that this would be a very valuable tool for REACH, for the chemical safety assessment under REACH, because it clearly demonstrates how chemicals can be used safely, using the very same sort of modeling strategy. Well, there's first of all SimpleTreat version 3.1, as it is used in users version 2, is recommended by Jaap Struijs to be replaced by SimpleTreat version 4. It has been discussed yesterday in all details, including the 7.5 milligrams per liter that he recommends as a realistic estimate of the amount of suspended particles in sewage treatment for plant effluents. The technical improvements made in SimpleBox have also been discussed yesterday. What we have not discussed in detail is the possibility of integrating all the different things that we need in risk characterization calculation into one simplified integrated model. And it's really my personal recommendation that the SimpleBox version 3.1, which is used in the uses now, is replaced by this integrated model that the Solutions project has used and tested, and which is ready to go. And I think that the preparation committee should sort of look at this as a possibility of being used in the update of the uses. Really, the recommendation is to replace the chemical safety criterion as it is now, and that is that PEC is smaller than PNEC, which is the same as the probability that PEC exceeds HC5 is smaller than 5%. The Solutions project used the probability that the environmental concentration exceeds the HC50 acute of chemicals. And they recommend that safe means, well, get this smaller than 10 to the minus 6. Numerically, that isn't very different from what's done in uses now, but it makes a lot more sense. It is understandable, it's easy, it is robust, it's scientifically sound, and ready to go. Well, this Solutions project, you may not know it, there's 60 people or so, and you recognize these two people from UFZ Leipzig. And if you look a bit more careful, you would even recognize me. In this Solutions project, the exposure estimation is done as simple as possible, right as done in uses. We have added an emission estimation routine to it, basically saying, well, from the various uses that can occur during the entire life cycle of a chemical, some fraction is released to the environment, add them all up, and you get the release of this particular chemical into the environment, just as it is done originally in the A and D tables and later in the ERCs. In this project, we actually used the SPERC tables from CEFIC. Use the classical SimpleBox, only focusing at the regional scale as done in EUSYS. EUSYS has the entire global nesting thing program, but nobody ever looks at it, and rightfully so, because everything happens at the regional scale, and even at the local scale, which ought to be nested inside there. And in this solutions model, we have nested it inside it, as it was done in a previous version of SimpleBox, not represented in this graph. And we have also integrated SimpleTreat into this model to create something similar to this. But most importantly, this model has integrated the impact estimation in terms of directly from the model calculate the probability that the expected concentration in the environment would be greater than the critical effect concentration, just as done originally in the SSD book by Van Stralen and Altenburg. And as I said, we tested the emission estimations done in solutions for this, and we got something like this. We applied Tom Altenburg's representation in which he scales the concentration axis according to the average toxicity and the standard deviation in it, so that the effects distribution becomes a standard normal distribution, and each of the chemicals has its own Gaussian probability density function, of which we represent here only the 100 chemicals with the highest probability of exceeding the critical effects concentration. And in this procedure, you can just add them all up in the mathematically correct way. It's sort of doing the concentration addition mathematically correct. And this results in this particular example, a probability of 59% that some concentration of some chemical in the aquatic system looked at exceeds an HC50 of a chemical. 59% is a pretty high number, but that's for all the chemicals together. Individual chemicals would have a much lower probability of exceeding the critical effects concentration, and they're usually in the neighborhood of 10 to the minus 6. This is why the solutions project recommends, well, if you now set the probability criterion for not exceeding a critical effects concentration at 10 to the minus 6, which is the negligible risk level, then you would be good. This is in a nutshell the results of this experiment that the solutions project did. It concluded that the emission estimations are greatly uncertain, as you would expect. As Valerie Forbes would say, they may be right on average, but at the same time, they may be wrong all the time, which is precisely what you would expect, and it's precisely what we found. But being right on average means, for this particular purpose, that you can work out the probability that one exceeds the other entirely correct, including the uncertainty that goes with it. Using the estimation rates and the integrated model was good enough to rank chemicals according to their expected impact on aquatic ecosystems. What we found was, in general, Pareto distributions of everything. Pareto distributions of concentrations in the environment. We all know that concentrations in the environment are log normal, and the right side of the log normal distribution is the same as the Pareto distribution, meaning that there's only a few chemicals that cause the entire effect on ecosystems. So Pareto distributions is usually referred to as the 80-20 rule. Well, this is kind of crude. There's all sorts of Pareto ratios to be found. In this particular case, we found that over 95%, usually 99% of the total impact is caused by only 5 and sometimes even less than 1% of the chemicals. Most of them being below 10 to the minus 6, meaning that this is better than negligible risk for most of the chemicals. Well, this is in a nutshell the recommendations that I've made already. We would keep on to the parsimony principle for exposure modeling, for impact modeling, and for the entire thing. And we would actually recommend the EU's updating group to consider getting back to the 3-compartment model. The nested air, water, soil, global scale model nested inside a regional air, water, soil unit world model. Set in the right parameterization would lead to a recipe that directly calculates toxic pressure expected in the environment from known tonnages of chemicals, which is exactly what chemical safety assessment in the each author. I think with this, yeah,